Hello, 8Es, receiving students and teachers. Thank you. You may sit down. All right, 8Es and receiving students. In today's lesson, our topic will be on converting capacity to volume. All right, receiving teachers and 8Es. That's our topic for today's lesson. Now, up here in front, I'm holding onto a shape. What type of shape is this? Oh, sorry, what type of solid is this? Okay, cuboid. Think it's a cuboid, a block, or a cube, all right? We can say it's a cube because we have the shape of a square, all right? Okay. Now, if you look at this cube, 8Es and receiving students, I want to find the volume of this cube. I want to find the volume of this cube. How am I going to find the volume of this cube, receiving students? How am I going to find the volume of this cube? Class? Or you forgot how to calculate the volume of a solid? Receiving students? How am I going to find the volume of this cube? What will I do? Receiving students? All right. We're always having Rachel all the time. Can we have someone else? Receiving students? All right, Abby?
Volume equals length times base times height.
Okay, thank you, Abby. All right. Abby said volume is equal to length times base times height. Is she correct, receiving students? Livingston, length times base times height, or we can say length times the width times the height, all right? So to find the volume of this cube, I have to multiply the length and the width and the height of this cube to get the volume. But I don't know the length and the width and the height. I don't know the measurement, so what am I going to do? Receiving students? Matthew?
Measure the sides.
Okay, measure the sides by using?
Ruler.
All right, you measure the sides by using a ruler. Okay, very good. To get the length, you measure the side, or you measure the length with a ruler. You measure the width with a ruler. You measure the height with a ruler to get your measurements. All right. Or I can simply do this. All right, receiving students and 8Es, look here. All right. The length, the width, this is the length, the width, and the height. So here the length is being divided into how many parts, receiving students? All right, into 10 equal parts. Okay, so what is the length of this cube? 10 centimeters. Very good, receiving students. See, the length has been divided into 10 equal parts. So what does this, let's say, what does one small square here represent? 1 centimeter, okay, receiving students. So here I have 10 centimeters. That's the length. The width, how many centimeters? 10 centimeters. And the height? 10 centimeters. So, receiving students and 8Es, what is the volume of this cube? Okay, you've given me the length, which is 10 centimeters, the width, which is 10 centimeters, and the height, which is 10 centimeters. So what is the volume of this cube? Okay, Winnie.
1000
cubic centimeter.
Okay, 1,000 cubic centimeters. Class, receiving students, do you agree with Winnie's answer? Yes. Okay, 1,000 cubic centimeters, because what did we do? We multiply 10 times 10 times 10, which gives us 1,000 cubic centimeters. All right? So, 1,000 of these small cubes, receiving students in 8Es. Okay, 1,000 of this will make up one big cube, or a block, one block, all right? Receiving students in 8Es. Okay, who can tell me what is the volume of this small cube? Receiving students? Okay, we know the volume of this cube. We know the volume of this block is 1,000 cubic centimeters. Okay. One single cube, all right? What is the volume of this one single cube? Okay, let's have Zephaniah.
1 centimeter.
Okay, Zephaniah, thank you. You're saying 1 centimeter. Now, I asked for the volume. Receiving students, is Zephaniah correct? No. Thank you, Zephaniah. Okay, let's have Andre.
1 cubic centimeter.
1 cubic centimeter. Class, do you agree? Yes. Yes? All right, 1 cubic centimeter. Why 1 cubic centimeter? Quickly, someone? John.
Because it has 1 cube and equal sides.
Okay, thank you, John. It's a cube and it has equal sides. Equal sides, and the length and the width and the height. How much, how many centimeters is the length? How many centimeters is the width and the height? 1 times 1 times 1, which is equal to 1 cubic centimeter. Okay? All right, 8Es and receiving students. So now you know the volume of this block is 1,000 cubic centimeters, and this small cube is 1 cubic centimeter. All right, now, if I were to pour water into this cube, or into this block, I want to find the capacity, all right? The capacity of this block in liters. All right, 1,000 cubic centimeters. In liters, it will be 1 liter, okay? Receiving students, 1,000 cubic centimeters is equal to 1 liter. Because this is 1 cubic centimeter, if I pour water into, let's say, into this cube, what will be the capacity? Receiving students and 8Es. Here we know that 1,000 cubic centimeters is equal to 1 liter. This cube is equal to 1 cubic centimeter. What is the capacity if water is poured into this? What will be the capacity? Receiving students? Okay, one of you from there, please.
1 milliliter.
1 milliliter. Class, do you agree with him? Yes. Receiving students and 8Es. If I pour 1 milliliter, all right, 1 milliliter of this water into this cube, it will fit. So 1 cubic centimeter is equal to 1 milliliter. Okay. All right, I want us to look at one example. Okay. because we are going to convert capacity into volume, or volume measurements into capacity measurements, okay? Now, firstly, it reads, an oil tank has a diameter of 5 meters, okay, and a height of 4 meters. How many liters of oil can it hold? Okay, again, receiving students, an oil tank has a diameter of 5 meters and a height of 4 meters. How many liters of oil can it hold? Okay, firstly, what we're going to do, okay, the question is, it's asking us to find the capacity of the oil tank, all right? But before that, firstly, what must we do? We must find the volume. Very good, 80s and receiving students. We must find the volume first of the oil tank. And then after we find the volume, now we can change the volume measurement into capacity, right, into liters. So firstly, what we do, receiving students, let's find the volume first of the oil tank. So because the oil tank is in the shape of a cube, cuboid, pyramid, a cylinder. Yes, remember, it has a diameter of 5 meters and a height of 4 meters. So we use the formula for calculating the volume of a cylinder, and then we get the volume. All right. Okay, calculate the volume first. So what is the formula for calculating the volume of a cylinder? Volume is equal to AH pi r squared, H. So what's, okay, let's say 5 meters, diameter of 5 meters. So 3.14 times 2.5, which is the radius, okay, of the diameter, 5. So 2.5 times 2.5 times the height, 4. Okay, can you work that out, please? Receiving students? All right? Okay, anyone with an answer? Receiving students and 80s? Okay, what is the volume of the oil tank? Receiving students? 80s, anyone? Who's got an answer? Okay, class, receiving students and 80s. If you multiply, all right, 3.14 times 2.5 times 2.5 times 4, okay, you will get the answer 785. What? 785 cubic meters, yes? Receiving students and 80s. That's the volume of the oil tank. Okay. Receiving students and 80s. 785 cubic meters. Okay. Now we found out the volume. Okay, we found the volume already. Now we have to change cubic meters. Okay, we're going to change it into capacity. All right. But firstly, before we change this into liters, we know that 1,000 cubic centimeters is equal to how many liters? 1 liter. Okay, 1 liter. So we have to change these cubic meters firstly into cubic centimeters. 785, okay, I'll write it up here. Change cubic meters to cubic centimeters so that it can be easy for me to calculate this into capacity, into liters. Okay? So we have to find out. If you change 785 cubic meters to cubic centimeters, what will it be? Okay, what will this be in cubic centimeters? Okay, just think about that for a while. Okay, sorry, let's just go back to the volume. Some of you got 78.5, Okay, yes, you are correct. 78.5 cubic meters, okay? 78.5 cubic meters. So, okay, that's all right. But like I said, we are going to change this into cubic centimeters. Okay? So what are we going to do? Change cubic meters to cubic centimeters. Class, this is what we're going to do. 78.5, okay, multiply by, okay, how many cubic centimeters is equal to 1 cubic meter? Okay, I'll draw a diagram and you'll try and understand from here. Okay. Oh, my diagram. Let's say, oops, my diagram is, I don't know. It's not really good. Okay. 1 meter times 1 meter times 1 meter, okay, which is 1 cubic meter. Okay, I want to find out how many cubic centimeters is equal to 1 cubic meter. So, how many centimeters in 1 meter? 100. 100 times 100 times 100. See, okay, 100 centimeters times 100 centimeters times 100 centimeters will give what? 1 cubic meter or 1, how many zeros? 2, 4, 6. Okay. 2, 4, 6 zeros, that's how many? 1 million cubic centimeters is equal to 1 cubic meter. Can you see? So, 78.5 times 1 million cubic centimeters. Okay? 1 million cubic centimeters. And that will give us, because you see, I want to change this here, cubic meters to cubic centimeters. So that's why I had to multiply by 1 million. 1 million cubic centimeters. Okay, because 1 million cubic centimeters is equal to 1 cubic meter. Right? So what's our answer? If you change this into cubic centimeters. Okay, just add the zeros. 1, 2, 3, 4, 5, 6. 78.5. What's our? Class? 78.5. Here. 78,500,000 cubic centimeters. Okay, receiving students? And 80s. Okay, so you see now you've changed this 78.5 cubic meters to into cubic centimeters. Okay, now it can be easy for you to calculate, change this into liters, cubic centimeters into liters. Am I right this way? X 78. Okay, class here, 80s and receiving students. Now the next step, I'm going to use the ratio method to convert cubic centimeters into liters. So we already know that 1 liter is equal to 1,000 cubic centimeters. Okay, 1 liter is equal to 1,000 cubic centimeters equals, we want to find how many liters is this. So this is X, unknown. Okay, 78,500 million cubic centimeters. So what I do is I'm going to multiply, okay? I'm going to multiply this interior here, 1,000 and x, and multiply 1 liter and this, okay? So 1,000 times x is 1,000 x, yes? Okay, so 1,000 x is equal to 78,500,000. Am I right? 78,500,000. Okay, now what am I going to do? Okay, I divide by 1,000 to get rid of the x, of that 1,000. Okay, so here I must divide by 1,000 too. Okay, receiving students? So I cross this off, cross this off. This is x equals 1, 2, 3. Cross off the zeros. 1, 2, 3. I'm left with 78,500 liters. 80s and receiving students? Okay, so you see, we went through 3 steps, okay, just to get the liters, just to get how many liters of oil could that oil tank hold. Okay, 80s and receiving students, we're going to stop here. And receiving students and 80s, you can do your additional activities for your homework, all right, for your homework. Receiving teachers, please, 80s, I'd like you to do exercise A and exercise A, B, and C for your homework, all right? Exercise A, B, and C. Receiving teachers, could you give those activities for your students to do for their homework? And later on, you can correct them, all right? So firstly, class, okay, firstly, you have to find the volume first. Find the volume first, and then what are you going to do? You convert the volume into capacity. Okay, don't forget our methods that we use, our steps. Make sure you get that. Okay, receiving students, if you are not clear, please ask your teacher for help. 8 is, make sure you can come and see us, the teachers, in your own time if you are not sure. All right, we'll stop here. Our key phrase for today's lesson, converting capacity to volume. And in our next lesson, we'll be looking at comparing between imperial and metric units. Thank you very much, 80s and receiving students, for your participation today. Thank you, 80s.